First, I should make a couple announcements. There are special events coming. The electronic Capture the Flag contest is up for embedded systems. So you can sign up here if you want to be on the team. The hardware came in a couple days ago. So these little gadgets, and you have to write the firmware for it, and then people try to hack your firmware to see if it's secure. So it involves coding and defending things. We're forming a team for that. And there's a hacking workshop coming on December 7th. That's extra credit. And here, and there will be a remote option. I think you'll be able to attend by Zoom if you don't want to come physically. All right. Anyway, so we're up to Chapter 11, which is Mac forensics. So this is not the iPhone, but the Mac computer. So there have been a lot of these Mac computers. I remember Apple had a Mac server. They never got anywhere. Apple's servers never caught on. But they got the iPod, the iPhone, the Apple Watch, and I think Apple Smart Speaker, and all these things are closely related, Apple TV and all that jazz. So the Mac file system started out in '84. It was replaced by HFS, and then at that time it couldn't write to NTFS natively. That was HFS. Now I think it's JHFS Plus. HFS Plus in 1998, and this had a bigger block size, so you can have longer file names and bigger files, and a catalog file. APFS is another one. I think this is what we're using now, Apple File System. This is the latest one. 64-bit file system with therefore a ridiculous number of addressable blocks, so an incredible number of files. Timestamps in nanoseconds. Copy on write. This means if you have two files that are duplicates, it only makes two pointers to the same file to save space. It has strong encryption, full disk encryption by default, with single or multi-key encryption, and versions of AES are used. The reason they don't just use a simple version of AES is because in principle, hard drive encryption, the standard allows that there might be multiple users of the hard drive, so there might be multiple keys used to encrypt different parts of it. Anyway, key bags store the encryption information, and there's a container key bag that has the volume key bag and the volume encryption key, and there's a key encryption key. And I think we'll get to this. There are multiple layers of encryption on the iPhone and also on the Mac with multiple different keys. All right, the iOS uses backup, device, escrow, iCloud backup, and user. These are different keys. So when the user enters your password, the file protection complete key is loaded from the key bag and unwrapped. The backup key bag is created when you make an encrypted backup, and the escrow key bag is used for mobile device management and iTunes syncing. So they have multiple keys stored in different places for different purposes. They have a T2 security chip, which is the equivalent of the TPM chip in Windows computers, that has effaceable storage, which I think means easily erasable. And the point is to store encryptographic data on a special chip that is not part of the memory that the processor can reach. So there's no malware in the processor could possibly steal the key. The main processor never sees the key. When it wants to decrypt something, it asks the T2 chip to please decrypt this, and the key stays inside the T2 chip. That's the idea. And that's why it's considered very secure. It's there to meet the military standard for a trusted platform for military security. And it means that it's almost impossible to steal the key. The only attacks I've known to steal the key for the Microsoft version, which is essentially the same thing, are to freeze the RAM, to put the machine in a suspended state so there's a copy of the key in the RAM and freeze it. Although I don't know why there would ever be a copy of the key in RAM, but apparently in Windows machines, with BitLocker, there's a time when that happens. And the other way is to actually dissolve this chip with acid, reach in with a tiny probe, and read the little voltages inside it. Joe Grand managed to do that for a TPM chip, although I don't know if he did it for the Mac's T2 chip. So APFS has face sharing, allowing multiple file systems to share the same underlying free space. You can grow and shrink volumes, and so on. So your physical drives can have virtual drives that are not connected to the physical layout. All right, so forensic examination Spotlight is the feature you have up here. They can search through the Mac by the name of anything. It's very fast. And this contains a search index of some sort. It caches data here. Files that are moved in the trash and then deleted cannot be recovered in their entirety. If you had a magnetic hard drive, I suppose you could recover them the way you do with with a forensic tool like the one we're using, but I think almost nobody has a Mac running on a spinning magnetic hard drive anymore. They're all using SSDs, and I think all the modern ones have garbage collection, so things you delete are almost certainly zeroed out within a few seconds, really gone. All right. Journaling is in all modern operating systems. This means if the operating system crashes or the battery dies or something in the middle of, say, a write operation, instead of just leaving corrupt, partially transferred data on the disk, it has a journal. It recorded what it was doing, so when you boot it back up, it will figure out what it was doing and finish the job, instead of leaving fragments of partially finished file transfers. So a DMG image is a copy of a file or volume, like a DD volume. And this is what most Mac software, when you install it, it comes out as a DMG, which you double-click that, mounts it as a disk, virtual disk, then you run that. Now, a sparse image is one that will grow in size as more files are added, and a sparse bundle is another way to do the same thing. The configuration files are now in Windows, all the configuration is in one binary object called the registry, which is stored as about 11 or 14 files in various locations on the hard disk. In Mac, you have plist files for property lists, and they're just all over the place, separate ones for each application. More like the way Linux does it, where you install Apache, and Apache has some config files. You install FC, every program has its own config files. They're in these plist files. Now, they are binary files. They're not easy to read by default, but there's a plutil that will present it in a human-readable form. So this is what the plist file looks like if you just print it out as a text file. It's got a lot of readable strings, but it's not easy to format. But if you use plutil, you can print out the data in a more readable form. There's a sleep image file that has a copy of RAM, so you can send your Mac to sleep and wake up and have your programs in there, just like you do with a PC. You put it in Hibernate. So originally, Hackintosh is still a thing. I don't know, I haven't heard about them much in years. Hackintoshes have been attempts to make a Macintosh on PC hardware. And they've always been they were technically illegal. They're a violation of the terms of service of the Mac OS, but hobbyists have tried doing it. It's very difficult because you don't have the right drivers for that hardware. Apple operating system only comes with the drivers for the Apple hardware. So you have to somehow modify the drivers from Windows and make them work, and usually it doesn't work very well. There have been a few of them available on torrents, and people make it as a hobby. There was a company that actually made Hackintoshes and sold them as Macintoshes, and they didn't work. And after a couple of years, Apple sued them and shut them down because, of course, they don't like that. That just defames them. But technically, they're all violating the terms of service. But if you just make one for your own use, Apple will probably never find out and never care. It's only if you start selling them that you really irritate them enough that they'll waste their time shutting you down. Anyway. Another thing you might like is an OS X virtual machine. And as far as I know, the only way to do that is to have a Mac and run VMware, and then you can put an OS X on top of OS X. But if you want to put it in on a PC, I think there is no legal way to do it, and even no practical way to do it, because you don't have the drivers for the hardware. And people try to make, there's things you can download where people have tried to make this work, but they tend to run very badly. And unfortunately, there's no free iOS emulator that you can run. The only ones that work are very expensive. Anyway, before OS X, Apple had its own proprietary operating system, OS 8 and OS 9, that was a strange mess, and I avoided them at that time. It seemed just like a childish toy compared to Windows at the time. But OS X is Unix, based on BSD Unix. They call it the most advanced operating system in the world, and that is not a stupid thing to say. Berkeley Standard Unix is one of the original Unix branches, and that's what it's based on. So now it's very serious, and it's worthy of respect. And I switched to Macs after Windows 8 came out, and I observed that Macs were now running Unix, and I said, well, now that's something I can respect. So they are up to 10.15. I think now we're up to maybe 10.18 or something. They keep having more versions. All right, but they're all very similar. So Gatekeeper enforces code signing for downloaded apps, and there are occasionally Gatekeeper bypasses where you can trick it into installing something that's not signed, but normally it requires a sign. Yeah, Sequoia is sort of an iOS emulator now. Good. Is Sequoia available? Is it super expensive? Let me take a look. Sequoia iOS emulator. No, it's an iPhone mirroring, apparently. Yeah. Is there a real iOS emulator? Xcode simulator, but that's not really an emulator. It only runs on Macs, and it's not like the Android emulators we use. You can cast your phone to it. Yeah, that just lets you see the face of your phone, but it's not really the same as having an emulator where you can study how the phone works. Anyway, so File Vault is their encryption tool, and typically it's on by default now when you install the operating system. It's encrypted from the very start, so if you lose your password, nobody can recover your stuff. This is the default. Now, you can save it with Apple, they say. You can choose to save a copy of the key with Apple, and if you did that, then if they send a subpoena to Apple, they might have the key. I know BitLocker used to do that too. I don't know if they still do. When you encrypted your Windows machine with BitLocker, they would offer to make a backup copy on Microsoft's cloud. And if you do that, then of course there might be a way to get it back from there. But if you don't do that, then if you lose your key, your stuff is all gone. Disk utility is used to format and repair disks and so on. The keychain is Mac's password manager. Very powerful, very nice, and it automatically synchronizes with iPhones and such. So when I put a password on one Mac, it spreads to my other Macs, which is very nice. iCloud keychain stores them in the cloud. And you have tags to label files, I think. And Safari, the browser, which is what most people use on the Mac, I suppose. Well, I guess a lot of them download Chrome these days, but a lot of people just use Safari. And on iOS, that's mostly what you use, mobile Safari. It's got a browsing history and downloaded files and a cache and cookies. Of course, it's got to have these things. You can also boot a Mac into target disk mode, where instead of starting the operating system, it's just like a removable hard drive. So you can read and write to it, and this is handy to copy the contents of the hard disk. All right, and there are some special ways to boot it up to try to recover if you lost a password and such. But I think with the modern encryption, these things don't work that well. I haven't really used these recovery features since Macs are encrypted by default these days. Used to be you'd hold an S or an R during boot up and you could get into single user mode and then you could reset your password. But I don't think that works anymore with an encrypted device. And then, of course, there's mobile devices. The laptops and computers have the full OS X. The smaller version, iOS, is just a smaller version of the same thing, both based on Unix, and that's what Apple iPhones have, and the other things like iPods and smartwatches and all that. So the mobile devices are, of course, perhaps the most useful because people do almost everything on their phone now, and it's got all their messages and photographs and contacts and emails and everything, so it might be the place to go. The problem is, of course, iOS is very secure and very private, and Apple wants to maintain their reputation of valuing your privacy very much, so they do not cooperate much with law enforcement. So now it's encrypted at the block level. It's got a unique device identifier, hard-coded into the processor. It's got a separate encryption key for each device, so if you chip off forensics is now useless. You can take the chips off and copy the data, but you're getting data that's encrypted with AES, and you don't have the key, so it's useless. Each time a file is created, it generates a new key for the file, and it has a restricted mode USB to prevent a trusted computer from unlocking it if you don't have the passcode, and everything's encrypted with AES 256, the strongest form of AES. They're really not messing around. And so, if you do have the passcode and you get in, then of course you find things here, and we've seen this. In iPods, you have directories like you have on an iPhone for music and contacts and calendars and such, and the iPad is very similar. And the iPhone, of course, we've already done iPhone forensics in this course. I think you got screenshots, deleted photos, call history, email, all the good stuff. There's a lot of technology out there just for Macs, special software just to acquire and analyze a Mac. Blackback, yeah.
These OSs are not the equivalent of the embedded operating system that we see for Windows, for example.
It is, I guess, what you call an embedded operating system on the phone.
Okay.
But
they're more complete.
they're more complete than the usual ones. If you had a smaller, simpler device like a doorbell, it would have a simpler version of it. That's why they come in all different sizes. And in fact, if you listen, there's a podcast called Security, Cryptography, Whatever, that is very technical, and they talk about how they have to find encryption that will run on like really small processors, so only a little bit of memory to put in these things. And so you have to, but they're all based on Unix, and then you shrink it down to fit whatever the environment you have is.
But what I'm saying is that they really have a grasp on each small piece of hardware.
Yeah.
It's not like the Windows version that instead is.
Well, some of them do. Your cheaper devices often have some sleazy firmware that's just been modified for something else. That's why, Apple devices are pretty good. But the cheap devices you buy for only a few bucks, they probably have something poorly written. That's why it's kind of fun to analyze them. You often find security flaws and such.
Well, I imagine the software, the embedded software for the ATM machines. So those are not supposed to be cheap.
No, they shouldn't be, but in fact, they've been hacked and stuff. The cheap ATM machines do have like default passwords that sometimes reset. So all I have to do is pull the plug and plug it in again to get it back to the default password, that kind of thing. But the cheap ones you find at like gas stations, those often are not very secure. The ones in the banks, I imagine, are more secure these days. But you never know. Anyway, so Black Bag makes them, and they're now acquired by Paladin. They make devices to software to image iPhones and Macs, and there's many others like Oxygen Forensics I've heard of, and we talked about Cellebrite before, and there's a lot of others. These are companies like Belkasoft and Magnet Forensics. These are all things you can buy to image iPhones and Macs, and they're all pretty expensive. So GFU version is direct firmware update, I think, something like that. So you can select the firmware version, and there's a recovery mode to restore settings to the original factory defaults. So when the phone is powered on, it gets boot code from ROM, and it gets a root CA public key from the internet to verify that the operating system is signed by Apple to make sure it hasn't been altered. So you can't put a rootkit on there. Then, after this runs, it starts iBoot, which verifies and mounts the kernel. And it has stages of encryption after that. And eventually you have to log in with a face or touch ID or a PIN, and then it uses that to make another decryption key. There are several layers of encryption. And it can use face or touch ID, which of course is less secure against police than a PIN. Because the First Amendment, you are allowed to refuse to tell them a password or PIN, but you're not allowed to refuse to give them your fingerprint or face. So they can force you to prof that up. Now, there's an iPhone backup. You can back up locally. I haven't done it. But iCloud is what most people use, of course. And Apple will prompt you, trying to get you to use iCloud, both because they make money off it and also because it is extremely common that people drop their iPhone and they want to buy a new iPhone and they wish they had their data. And so you really should back up your stuff because, when you lose your phone, you'll want to have your photos and emails and everything. I just recently learned, I didn't know this, apparently if you pay for iCloud, you can back up your Mac to the same iCloud account. One of my customers I'm consulting for says that's how they're getting a backup. I wasn't sure that would work. They claim it's working. I haven't tried it.
Yeah, but then whatever you upload in the cloud is not yours anymore.
Well, Apple will protect it the same way they're protecting your local stuff. So the question is, do you trust Apple? And Apple has really worked hard to be trustworthy. They will cough it up if they get a court order, but they won't just casually lose it. So you're right. But you're right. If you don't trust Apple, then you can't do it. But there's not much point owning any Apple devices if you don't trust Apple, because you pretty much have to give them your credit card and buy in their store and everything. You pretty much have to trust Apple. It's like joining a club. You won't really get much benefit out of it if you don't trust them and give them your credit card and buy their stuff and subscribe to their stuff. They get a lot of money. So most Apple users are content to trust Apple. I am too. I'm not using iCloud, but I could be. Maybe I should. I think it'd be cheaper than the Google Drive I'm using. Anyway, you got photographs, and of course you have location data stored on the phone, which you've seen before. And it uses not only the GPS, but also Bluetooth and Wi-Fi maps to try to locate you more precisely. All right. And you can search by latitude and longitude through data to find things. Checkmate and Checkbrain are two exploits developed by one of the students in my classes who was a Google engineer, and he took my classes and then found out how to use IDA Pro to reverse engineer things, bought the expensive version of IDA Pro and spent a month hacking into the Apple boot up process and found a flaw, which led to the latest jailbreak, which he called Checkmate and Checkbrain. These are go up to, I think, iOS version 11, and they're in the hardware, so they can't be fixed unless you buy a new phone. So you can jailbreak those phones and gain complete control of the operating system, something Apple does not want people to have. Security researchers want to gain that to analyze the phone. Apple tries to lock people out. So this is the most modern jailbreak. Hit the side button 3 times to reset Face ID. Oh, I didn't know that. Okay. That's interesting. All right. And so is another tool that pulls out SQLite database, a tool that just pulls those databases out because that's where most of the good stuff is, possible forensic tools. And so, if you're going to examine a Mac, you understand what type you have, figure out what ports you have, and how you're going to image it. I know when I've done research on a Mac, I didn't have any of this equipment, so I just wrote a bash script to get the active data and said, that's all I'm going to get. Remember, you don't have to get everything. It would be perfect if you could copy everything, but you might not have the ability to do that, and your case might not justify going to that much work, so you do what you can. But whatever you do, keep notes. And then you can say, here's what I did, here's what I found. Like I say, you can just take photographs of the screen. That's evidence too. If you just look at it and testify, I saw it on there, that's also evidence. Your procedure does not have to be perfect, although that would, of course, be nice. There's an FCC ID, which will help you track down the type of device. Apple has a website where you can find out the technical specifications. That's one thing about Apple. There are all these generations of hardware, and it's not easy to find out which one you have. When I read about exploits affecting certain Macs, I often have to go up to websites and stuff to figure out exactly which one I have. Anyway, that's the game. Typically what you want is a DMG image of the hard drive and then mount it with a forensic tool. But for instant response, you might want to image the RAM just by getting running processes and such with command line tools, or using Velociraptor, which we'll use next week. Velociraptor has forensic examination tools that do live forensics where they capture not everything from the device, but the most important stuff, list of files, list of running processes, and things like that. Perhaps memory images from particular processes that look suspicious. That's the sort of thing you do for instant response. All right, and I'm looking, okay, no new comments. There's more of this. All right, so then there's, of course, the Internet of Things, all the other smart devices we have, little GPS gadgets, smart light bulbs, smart thermostats, webcams, smart refrigerators, everything is smart and has a computer in it these days, and all those computers have data.
Colors.
Yeah, sorry,
Animal colors.
I've heard of shock collars, but I don't, what other?
Well, shock colors, yeah, maybe a functionality, but there are some colors that track the habits of the dog.
Dog
how
collars,
much
yeah.
they walk,
Oh yeah,
the
dog
distance,
collars, yeah. And now the smart glasses with the cameras in them and stuff. Yeah, everywhere there's these gadgets, and so it's almost impossible to imagine that you would have the hardware ability to connect directly to all these devices, but you can understand their general principles, and that's why this embedded device, Capture the Flag, is a good thing to learn. How to control these things, make them, how to break into them. It's useful information these days.
Because I think these are pretty simple operating system, I would assume. This is the first generation.
I think they are, but there's general techniques like learning to use JTAGs, which are chips that suck the memory off the ROM chips, and then learning how to unpack the packed file systems. The operating system is typically sort of compressed, and there's a tool called Binwalk that unpacks it, and there are other tools. It's included in Kali. So you have to get the firmware, you often have to decrypt it, then you have to unpack it, and then what you find is a Linux-looking file system. And so, they're all quite similar, but this is a whole branch of hacking. And like I say, we should have a hardware hacking class. It's unfortunate that we don't. Maybe we will one day. We are going to have Liz again next semester, and she's the expert. So maybe within a few years we'll have a hardware hacking class. The same thing applies, by the way, to car hacking. Cars are computers, and they have a CAN bus. They have a special protocol, and you can hack into the car that way, and they do it at all the security conferences now. Just like the Lockpick Village, they all have a car hacking village. And you can go there and practice hacking into cars. So often you can't directly forensically image them, but often you can find some way to get some of the data off them. And of course, they got Wi-Fi, and Shodan is a tool that will let you look for insecure devices. The main thing people do is here look for insecure devices just so they know they can be hacked. Because the Shodan is a search engine that indexes not the contents of web pages like Google, it indexes the firmware version that everything is using. It just makes a connection over TCP and gets the response, which typically is like a version string. Here I am a webcam model 7 from this company or something, and so from that you can tell if it is the old version or if it's been patched often. So when somebody has a new hack, you go to Shodan and you can find out how many devices are vulnerable and still connected to the internet. Alexa is Apple's smart speaker, I think. It's Google's. It's one of them. I think it's Apple's smart speaker. Google is called Siri. No, Apple's Siri, right?
Alexa's, no.
Alexa's Amazon, I think. Yeah, yeah. Anyway, it's one of the smart speakers, which those things seem to come and go. They were all the rage a few years ago. I think most people admitted they pretty much quit using them. Anyway, but they do. The thing about them is they're always listening to you, of course. They have to be listening even when you're not saying the magic word to see if you said the magic word. And it came out that we were in fact sending the data up to the server all the time. So they're kind of like a bug in your home, recording everything.
There are people who use microphone jammers.
Microphone what?
Microphone jammers.
Oh, microphone jammers. I did not know that. Okay.
Yeah. They put into the jack, whatever jack is available, and I mean it's not 100% secure.
Yeah.
But at least they'll create some noise.
Yeah, and that's an issue. If you have one of these things running, anybody can talk to it. Yeah. And then you got fitness trackers, Apple Watch, microchips. You can put them under your skin. I've got a friend that has a few of these. If you don't feel like carrying around ID cards, you can embed the chips under your skin and have them built into your fingers, and so on. And it can do anything a chip inside a card could do in principle. And you can request data from the Apple Watch, from iCloud or the phone. The Apple Watch, of course, knows where you've been. It knows what your heart rate was and things like that, like a fitness tracker. And of course, there's cameras that people put all over the place, often dashboard cameras, and that's often important information. And police are now wearing these police cameras all the time to record what they do, which is probably a good idea to help prevent police brutality and such. And then there's drones everywhere, flying all over, taking pictures of everything, and cameras people put in the street to monitor everything. So, I think I read, like 10 years ago, I think I read that the average American is photographed 150 times a day. And I imagine it's a lot more now.
And it's a lot more in China.
And
China is the most extensive social surveillance system.
Yes, and in China, they're actually rating you with like a social score of whether you're a good person or not. In Britain, they're not only photographing you, they also have microphones in every corner to record what you're saying. That's illegal in America. There's special laws from the, before any of this happened, from the old telephone days, there's laws about recording speech, which are strict in America, but recording photographs in public spaces is allowed. So that's why you don't have audio on the surveillance cameras in America. And of course, the Ring doorbells, Amazon sold these to everybody, and they said they're much safer because you can see who's out there before you open the door, and you have a recording of them if somebody's coming up stealing your packages. But then they said also encouraged you to send that data to the police automatically, and everybody started doing that, and then people said that was a privacy problem, and they argued back and forth. I think a lot of homeowners felt like that would be fine because they want to discourage crime in their neighborhood. But
there, I remember there was a dispute.
Yeah,
the police was involved there.
Yeah.
At some point, even police was actually actively looking for those kind of data.
Yeah, I mean, the police would like it, would like to have extra cameras everywhere monitoring everything, and the privacy advocates would like them not to have that, and the battle goes back and forth. So police vehicles have to be connected to the internet all the time these days, so they have a special standard just for this purpose, for vehicle-to-vehicle communications, and it's a cellular protocol so they can transmit to the internet and get information like building blueprints and check people's criminal records and cars and such, GPS and all that jazz. So, like I mentioned, vehicle forensics are a big deal. Cars are now computers on wheels with all kinds of data in them. The GPS in your car is keeping track of everywhere you go and recording it, even when you're not using the GPS to go places. There is a record inside there that can be recovered. And so all these electronic devices, you can try to track them down by having dogs. Dogs can sniff electronic devices because they all leak out certain chemicals, just like explosives, so they can find the electronic devices that might be hiding somewhere. And of course, another thing they don't mention here is the big thing is the AirTags and the clones. Now you can get a little device the size of a quarter, put it in something and track it where it goes. People do this to find out where their luggage goes, and stalkers slip it in like a woman's purse to track that woman and find out where she lives and stuff. And this is a big problem. So about a year ago, the police asked Android and Apple to add a feature to their phone that will tell you if a tracker seems to be following you that's not yours. I mean, somebody slipped one of these in your car or something. Now, the modern versions of the operating system supposedly will tell you that. I know for me, it's constantly popping up telling me I've lost my laptop. About 6 months ago, my iPhone started telling me that I'd lost this laptop I'm using here because every time I turn it off, it thinks it's gone. So when I drive away, it will say, "You forgot your computer at the college," when it's right there next to me. But because it's off, it thinks it's gone. And it offered to turn that off, and I said turn it off, and it just came back on. So anyway, I think this attempt to protect your privacy from the tracking devices is not working too well yet. But that is something that is a modern issue. All right, let's see. Beijing is a trip if you're never not able to see a camera. Yeah, I've heard this. I didn't notice them in Beijing, but the students that were there watched television. They said television has tons of shows which are from the cameras, showing all the traffic accidents and people doing stupid things on the roads. Because the traffic is appalling. Everybody drives like a complete idiot with a death wish. And they do constantly get hit. Every time you took a taxi ride 10 blocks, they'd have to go around an accident. There's constant traffic accidents because everybody is completely insane. And apparently there are cameras everywhere recording it. So in addition to getting clobbered, you'll probably get in trouble with the cops if you live. But I've never seen people drive like that. It's unbelievable. Every single person just acts like they own the whole road. They'll just take like a bicycle or cart and just walk right across a busy road, go the wrong way, stop in the middle. It's crazy. Anyway, that's Beijing for you. All right, well, that's all of this chapter 11. Let's try a Kahoot. I should have a Kahoot for this. Let me get logged in. My glorious Google account, I think, is what I'm using. All right. And I should have module 11. There's 10. Hey. What else can I sort by? Name. That would seem good. There it is, 11. Okay, good. Hey, they didn't used to have a sort option. This product has been improved. All right. Someone asks if I know vulnerabilities on autonomous cars. The only one I know is there are ways to fool the AI into not seeing things. That's what I heard. The Chinese autonomous cars, which are the big ones, there's a way to make a sort of bumper sticker sized thing that you put on another car, and after that the AI doesn't recognize it as a car. If you consider a printout of a stop sign to get a car to stop, yeah, that kind of thing too, that's right, yep. You can of course alter street signs, and the autonomous car will be fooled by it. Of course, humans would probably be fooled by it too, if you did it kind of well. And I guess, like Bugs Bunny, if you would take white paint and paint like a curvy thing in the road, the autonomous car would probably follow that into the wall. I mean, I bet that would work. I haven't heard of people trying that, but I think that would work.
So Sam, considering all the restrictions that Apple puts on operating system, on the machine, etc. Okay, if I format the hard drive, how am I going to reinstall the operating system?
Well, formatting the hard drive does not erase the contents. It just marks it as empty for reuse. If you want to erase the contents, you have to write on every sector. And for a magnetic hard drive, that takes hours. And you have to use a special command. It's in the, you'd use DD to do it on a Mac. You'd use disk clean all, check disk clean all, I think, on a PC. And that would take like an hour or so to write to every block. However, for SSDs, it would just be enough to delete the files, and in the background, it'll run over them for you.
So, okay, but does this mean that if I format the hard drive of a Mac, the operating system remains there? Because there is a process of restoration
If you format the hard drive, I think the operating system is gone.
Right.
And on an SSD, probably all the data is also gone. On a magnetic hard drive, the data would still be recoverable with a forensic tool.
Right, but now my interest is only to install the operating system.
Right, if you just want to, that's right, just format it, that's the point. It cleans it so you can put on a new operating system. Absolutely.
And how do I get the operating system? Because it's not that I connect, it's not like Windows that I connect to the...
Yeah, you usually have it on the USB drive. There's usually a tool to make a USB version of the iOS. Kirk does that, of the iOS 10. It's not common, but you can do that. You can get a recovery USB stick. At least you could in earlier versions of OS 10. I haven't seen them in years, but I bet you can still do it.
So, but then it means, okay, if that system is in place, it means that I can install their OS on any machine.
I think so, and I don't know if it'll catch you for violating the license terms. I'm not sure. Yeah, on another Mac. That's the only thing you can put it on is another Mac.
Right.
Yeah. All right. Yep. And but this kind of repair is not common. But your Apple techs do learn how to do it, how to reinstall the OS and such. I've seen it done. I've never done it myself, but some of my friends do that. All right, let's give it a try. All right, so what chip has the encryption key? It's the T2 chip in the Mac. It's the TPM chip in a PC. Both do the same thing. A cryptographic coprocessor that stores keys and does the decryption. All right, so what files are like Windows registry files? The plist files have the settings for all your applications, which is what you'd put in the Windows registry. Configuration files. All right, so which feature enforces code signing? That's Gatekeeper. This is the thing, if you download a file like Hexfiend on a Mac, you won't be able to run it at first because it says, no, this has been downloaded from the internet and it's not signed by a trusted provider. So you have to go adjust your security settings to allow that. By default, Macs will not let you run anything that's not signed. And you have to turn that off if you want to take the riskier policy of downloading things. Almost everybody turns it off, of course, because they want to download freeware and use it. But if you leave it on, then of course you're safer. Anyway, that's Gatekeeper that does that. All right, so what do police cars use to reach the internet? That's it, vehicle to everything protocol. I was thinking it might be TPPO, but that's the chemical electronics leak out. So that's it, that's the protocol. So it's a moving car reach the internet. The hoots here.